In earlier videos, as part of the digital logic series, we talked about truth table, compressing truth tables. Same approach can be used to compress K-map. In some ways, K-map is easier because if you remember when we were doing the truth table compressions, we always had to make sure if you wanted to compress a truth table with respect to a particular variable, that variable had to be the least significant variable. In the case of a K-map, that's not an issue. Let's go ahead and draw a sample K-map, and then we can kind of chat about see it exactly what we're talking about in terms of being able to compress around any variable. So if you take a let's say take a 4 by 4 for this example, and let's say we have A, B on this side, C, D on that side. Let's say this is a K-map given to us, and as you can see, we can so let's say for example they ask us to compress K-map K-map around or with respect to let's say A. Now, in the case of a truth table, we had to rearrange the truth table to get there. The beauty of it is because the K-map is designed such that every row is next to the other row. In a sense, you can just find out which two rows have to be combined in order to get a variable out of the truth table. So, for example, for the A case, if you look at it, if I want to get rid of A, then all I have to do is I have to combine these two. You see, if I combine these two rows, then I'm end up with B, C, and D. And if I combine these two rows, then I can get rid of A completely out of this truth table. So let's go ahead and get over here. So if we do not have A in here, and we are compressing the K-map with respect to A, then we'll end up with B here because A is no longer there, C and D. So we'll have B0, 1, and C and D are staying, so we'll still have 4 possibilities. Okay, so now if you're gonna compress it, in here, what we're gonna see is that in the case of B being 0, which is the top row here, and the bottom row here, in the original table, then when we combine it for this square, we will be looking at this square and this square. We see both is 0, so we put a 0 in here. We see both of these are 1, we'll put a 1 in here. We see both of these are in the case of A, B, 0, yeah. And in this case is 1. And then the last one we see when A is 1, it is 1, and when A is 0, it is 0, so this is an A. And then the middle one's a little easier because they're right next to each other, so we can compare them. As you can see here, for this cell, if you're looking at these two, 0 and 1, they're matching what A is, so this is an A. Here, it doesn't matter what A is, it's 0. Here, they're matching A. And on the last one, it's reverse of what A is. So there, we compress this with respect to A. And as I mentioned, you can compress it without having to rearrange anything. You can compress it in every direction. So maybe compressing K-map is a little bit easier than truth table. But most of the time, you either are compressing a truth table or compressing a K-map, so you don't have a choice to decide to do something else. As just a completion, let's go ahead and check something else. Let's say they're asking us to compress with respect to D in this case. So let's say if I wanted to have a compressed K-map with respect to or around D. In that case, then if I'm going to compress around D, then I really don't need 4 columns. I only need 2 columns, but I still need my 4 rows. So that's what we're going to do. Our A and a B have to stay, and we're compressing on D, so D is going away then from the input side. So we're only going to have C. In this case, you can see that if you're going to compress around C, and in the case of C0 and 1, in the case of C0, you got to combine these two, and in the case of C1 equal to 1, you have to compress the other 2 columns. So let's go ahead and first take these 2 together and come down here. So in the case where A and B are 0, 0, you'll see that in this case, when D is 0, it's 0. When D is 1, so this must be a D. With this one, it's 0 either way. This one, it's D not, because when D is 0, this is a 1. I'm sorry, D is 1, this is a 0. That's right. So, and then the last one is D. Then you go over to this other 2 column and do the same thing. So you say, okay, when A and B are 0 and C is 1, what does D do to the output? It's the same as that. And then you look at the next one and you see, okay, what happens here. You see that 0 and 1 is opposite of what D is, so this is D naught. And then you're done. Here's D, and the last one really doesn't matter what D is, it is equal to 1. There you have it. So this is compressing a K-map, very similar to truth table with one additional flexibility that you really don't have to redraw it to get the variable to be the least significant bit, because you always can find 2 that are the 2 values of this given variable, regardless of where those variables are in terms of significance. That brings us to the end of this video.